we have a special bit of gear today, or at least a potentially deadly one. Now, because of a video loss, I had to just restage this first bit, but when we got it out of the back here, I'm not sure if you can see, but there's a DC in and there's a little square hole. Somebody had taken this power supply and put a lead through there and soldered it into the back of that socket for reasons unknown. On top of that, this is how the power supply came. There was a little bit more insulation tape wrapped around it, but crucially the mains voltage, active and neutral, were exposed, and there's a low ESR capacitor on here that's enough to kill you as well. So of course my Leatherman chopped this off the moment it saw it. It's a good Leatherman, saved me a lot of electrifying, but the task has fallen on me to find out why, how, and all about this. So let's see what we can do with this. Alright, let's have a look in this thing. I'll adjust our camera up a little bit. Apologies about the beep 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 in the background. That's a forest fire warning on an app I've got. There's been a major bushfire in the area that my fire tower watches over. I'm not currently allowed in the area yet, but I will be soon. And there'll be a video and documentary on that soon. I also had some surgery yesterday. I required a general anaesthetic, so my voice might be a little husky and I might be a smidgen slow. Let's have a look under here. Well, already I'm liking this. The battery pack has a nice little quick connector under here. It's very nice. And I'm noticing, we can see here, there's already a bead of dry solder's just fallen off something, so that says amateur's been in here. And we've got our nice mechanism for the foot pedal, that's good. And I can see here where this cable's come in. Let's flip this around so we can see. This cable in the top here has been threaded through that hole and soldered to the back of the socket. I'm not sure what retarded idea they were thinking there. They could have gone, if they had a soldering iron, they could have just soldered a plug on, but that's going to get snipped right off there. And there's some dry solder joins on the back here as well. So, and there's a few of them in here. There's been some amateurs in here, and there's some little marks as well. So I think it's had some work done. I'm going to have to pull this apart. There's also a suspicious mark here that looks like somebody has spot welded some new copper standoffs in here. So it looks like this might have been a dodgy repair. Like most things that end up in my lap. It's the two hard basket jobs. So I'm going to skip forward a bit here and see what else we can do once we clean this all up. I'm going to try and position this hopefully in such a way that you can see roughly what I'm doing here. So first of all, I need to tin the iron a little bit, because this has either been some lead free solder or some manner of witchcraft where they've used in here that was using the wrong spell book or something, I don't know. I'm going to remove these off the back of that socket. And they've buggered up a bunch of through plating in the process as well. So maybe we can just mix a bit of fresh stuff in here and at least clean that up just a bit. Oh, man, of monkeys have been in here. Straight off the bat, I'm going to have to clean up so much of this. What do we got? In the words of Moss from the IT crowd, amateur hour. Let's get rid of my ID card out of the background here. Probably don't want to be looking at my defence ID card. The kid goes to school on a RAF base. So, and there's some, there is lots of nastiness on this board. Right, I think first, before I do anything else, where's my tin of contact cleaner over here? It's pretty horrible. Let's have a look here. Nearly got that in my eyes. Wear safety glasses, kids. Give this whole board a clean up, and then I think I'll rip the board out of it. Let's have a look here. Yep, I think I'm going to start pulling this board out. And parts of me that I had some surgery on yesterday are a little bit sore. I might need to take a break for a moment, and we'll be right back. Alright, so we're back again. I think I'm going to try and find another auxiliary light source here so you can see what's going on roughly. This might... Not sure, how do you reckon that works? We can see it a little bit better. Some of what's going on in here, there's a bit of rust coming off this. I'm not sure why, but there's obviously they might have used some acid core solder when they've done this, and the acid, they didn't bother to wash it off, and it's rusted some of that, which is now sprinkling across the board. Not particularly ideal, but I'm going to take a bit of contact cleaner here and see if I can just brush this up a bit. Now, I've had a look at how this board comes out. One of the problems I've got is I have to remove every single knob on this, and there's about 40 or 50 of the things. Now, I had a sneak underneath with my little inspection camera just before, and I can't see any sign of an identifiable regulator. So I'm thinking the safest bet I might do here is to stick a bridge rectifier in it and put a 7809 regulator, so that, and either piggyback off the back of this and disconnect it, or run a whole new socket in here. And that way, at least we'll be able to plug it into just about any power source. But I'm not sure how I'm going to resolve this problem without getting the board out. It could be tricky. So I'll do a little bit of thinking and we'll see what we can come up with. Just been doing a little bit of research here, and it looks like, whilst it's not officially listed on the site, looks like these are designed to use a center negative 9-volt AC. However, as the battery is also 9 volts and it's DC, being the nature of batteries, fed right in here, should theoretically run off 9-volt DC. However, I've got about 3 million plug packs in a bucket in my shed, so I might go fish through one of them and see if I'm lucky first. However, one of the first things I really want to do is just have a probe around on this board with a multimeter and see where the negative goes, just to back that up. Because I've had experiences before where this has not gone that well. However, I happen to have put my multimeter in an unusual position. So here it is right here. It's tangling up in everything else that you can't see off screen. I have a desk upgrade coming soon, and that will be part of this. So let's check over the diode check. It's as good as continuity. One of my desk upgrades coming will be a desktop continuity checker that I'm designing. Nothing fancy, but a beep beep when you connect the leads is really handy. So we're going to assume if this is really center negative, we need a way to check this. Alright, let's change tack slightly here. I'll get a different screwdriver. One such as this should do the job. My good old Stanley collection with my names laser etched into them. Okay, that gives us a probe. Now, just to demonstrate what happens on diode check, when we get a short, we should go to 0, we should get a 1 when it's open circuit. So what we're doing, we're checking off the center here, we're checking firstly off the chassis, which, let's put a bit of light source in so those of you at home can see what's going on here. That may have made things worse. Let's have a look here. That looks much better. Okay, there's our meter reading here. So we're going to check off that center pin, which we believe to be ground, and we're going to go off the chassis somewhere over here off the screen. And there we go. We've got continuity. And let's try one of the ground traces, such as here. Yep, that looks good, and we'll just check across the board. That is definitely that. So let's check off the switched connection here, because it might be a switch socket that will only allow you to run battery when it's connected. So that's certainly not connected to anything. The little tab they'd connected their positive to. Oh, interesting. That's probably a capacitor charging up, I think. Yeah, it's not doing it now off any of the ground traces. That's off a positive trace, and nothing off the chassis. So it's most definitely, yeah, so you can see here when I touch this, a component somewhere is charging up briefly and then saturating. So it's most definitely center negative. Very worth checking that. I think the theory of it being 9 volts is backed up by the manufacturer's site and all the aftermarket supplies you can buy, on top of the fact that it uses 9 volts with a battery. So I think it's safe to say that's a 9 volt AC pack, but it also is got center connected to ground. There's probably some rectification in there as well. So let's go see if we can find a 9 volt AC pack. I think I saw one a couple of years ago. Alright, so before we get too in depth here, I better dial up a voltage and just test this first. So let's wind our current up a bit. Wind our volts up to about 9 volts. We're going to test this on DC first and just see if it fires up. I reckon in order to run an LED, they've got to rectify it back to DC anyway. My inkling is that it's a DC input will be fine. Now, my crudely connected banana plugs, I've ordered like 50 proper ones of these just recently, just this morning. But this red one with a red flag is usually what I use for positives, but we're going to plug her into the negative because that goes to the center pin, and our yellow ground tape is indicating that we usually use that for negative. So we're going to do that backwards, which feels really, really wrong, I have to say. So we have a 5.5 2.1 plug here, which I'm pretty sure will fit this. I'm just going to double check with a multimeter, because whenever I do something that doesn't feel good, that's usually an indication that I'm doing something wrong. So double and triple checking is a great way not to blow up customers' hardware. So let's select our 20 volt range here. Normally I would connect that to the outside and that to the center, and we're seeing -9, which is what we would expect to see if it's center negative. And I'm just going to double check the supply here. Yes, we have double checked it with the multimeter inside. I think there's no real way other than to do the smoke test. Let's try this now. Well, I heard a relay click and I'm seeing some LEDs on. That is promising. Okay, so do we have any kind of an on or an off? I've got an off and an on, and there's a bit of a flicker. Now, how much current is it pulling? Oh, pulling about 200 milliamps, not much at all. Oh, and we're seeing some circuits come on, and a delay, and a tuner bank. Oh, and our digital display is actually functioning. Okay, I think we're doing pretty well. Things seem to be happening all right. I don't think I need to do any major mods, and I might save myself a regulator here if this DC supply works. So let's turn this off, and we'll fly back up the top here to my supply here, and we'll shut you off, take my banana plugs out, hang them into the usual hanging nail over the top, and we'll come back down here, fly back around and give you a sneaky shot at the stuff on my screen. It's mostly just YouTube channels. Now, owing to this experience before, when a plug pack ends up in my junk collection in the shed, there's often something wrong with it. So let's just plug this in, and being it's a double insulated thing, try to make sure there's no ground looping or something silly happening with it. So we're going to plug it over to my RCD protected board here. I also use RCDs on my def leads too. If you don't know what def leads are, they're leads, two exposed leads connected to a 240 volt mains plug, and they are very aptly named because they do have the potential to kill you. So let's have a look here. I bet you this is not center negative. This will be center pos, and I can't get in there, which means we need a smaller screwdriver. Let's have a look over here. Let's grab one of my jeweler's drivers and let's see what we can do here. This little guy, these might not be conductive due to their coating, but we'll see. Alright, yes, so we're seeing on the meter 9.14 volts. So it's not over or under voltage, that's good. It's just the polarity is incorrect for this. So let's chop that plug off and fit ourselves another one, which I'll do once I clear the desk and get prepped. Okay, so we know that a 5.5mm / 2.1mm inner plug will work. We tested on that. We're not using a rectifier or the linear regulators. We're not using them. I'm just going to use this. In case you're wondering, that's the part number from JCar. So let's rip this out, get ourselves started. Now, pro tip, unplug it before you do this, because these things have a habit of shorting it out. Now, if I had my proper toolkit in here, I'd use an automatic stripper. Sometimes they can be nasty on these things. Second pro tip, as I learnt from doing swing stage leads, put the shroud on first, just so that you know swing stage leads are 100 meters long. And when you're putting a 3-phase plug on one, your options are chop it off and start again, or thread the shroud down 100 meters of cable. Either way, it's not fun. And this is some nice quality shielded cable here. I love this stuff. This is actually a 9-volt laptop plug pack, I believe, from a little compact plug pack. Now the shroud will commonly be negative, and this will be the positive. But as usual, we're going to err on the safe side and check this first. However, before I plug everything in, we are going to check this up. So that's my guess for negative, based on the experience. And I know I'm a little shaky at the moment, but there's reasons for that as well. Now let's take our mains plug, which is currently unplugged. Can we see the multimeter on that? No, we can't. Let's pull some blue tack around the side, and hopefully we can see what's happening here. There we go. LCDs and Polaroids, not fun. Let's plug ourselves in and flick our isolation switch. It's righty-o, so that is indeed negative shield, as I would expect. Probably a bit of drop off from the capacitor as well. Oakley dokley, as Ned Flanders would say. So let's have a look here. So it looks like our soldering iron is nice and hot. Now, need to make sure that whatever I do here can hide inside the shroud, so we might strip this right back to about there. We'll get our solder, which is hiding up the screen here a little bit, and we'll tin this right up the base so we get the straggler out of the way. Nice and hot. Actually, it looks like I need some extraction in here. Let me just sort that out. Sorry about the background noise, guys, but better than lead fumes in the lungs. So this plug is not really designed for this diameter of lead, so what I'm going to do here, so I'm going to just tin this, and I'll pre-tin the plug and go from there. Sorry if this video is running a little bit longer, but as I said, I need to go a little slower than average because of extenuating circumstances. Let's chuck get our lead out of the way here a bit. Now we're going to tin in here and touch, and across the top here. Okay, so this again feels super wrong. Super wrong. Putting the positive to the outer shroud, and then the negative to the inner, which is actually a smidgen short, just because I'm so used to doing it the other way around. This really goes against my nature. Really does. This is also a time for my trusty Leatherman, because my good side cutters are not kicking around. Well, now this I've just spotted is going to present a problem. This clamp on the back here is traditionally designed to make contact with that outer shield. That's not going to be the case the way I've done this. It's already actually creating a dead short. I'm going to have to rethink how we do this. I might have to chop this and redo this bit, which means I'm going to clean up things and do another take at this. Give me a moment. Right, so here's plan B. I've actually chopped that other one off short, as you might be able to see here, because it didn't seem to be any way, even with a bit of heat shrink, that I could resolve that join. So I'm actually going to cut these about the same length, and I'm going to solder them in. Now I need to just pay a little bit of attention here and make sure that I'm actually putting things in the wrong place. And you heard that right, I said wrong. Now I'm confused. Alright, so that would normally go there. We're going to flip that around. Oh, this is wrong. Intentionally reverse polarizing a plug. It's actually kind of difficult to do because they're designed not to do this. just some of the reason I'm having this trouble. Why audio equipment uses center negative is beyond me. It means if you drop your lead on an earthed chassis device, it's going to short out and blow a fuse somewhere. I'm not sure whose genius idea that was, but I think it was, I don't know, crazy like a fox or something. Right, now I'm a little worried about that. That's a little bit better. A little worried about that, and I don't seem to have any heat shrink left of the right diameter. So what we're going to do here is a nifty little trick for these situations. We're going to stick a bit of this to my sacrificial bench top, cheap melamine, take the square edge knife, and we're going to run a little strip up like so. I think I'm going to need 2 sections of half that, and then we'll peel the end up. Right, so now we're going to go in between these contacts, because I can foresee once the shroud goes back on that we will have a short circuit event, which that's not like the premiere release of Short Circuit 2, the movie. This is a far more catastrophic event. Alrighty then, so I can see here we've got that fairly well insulated. I know I haven't just wrapped around the outside, I've actually gone through the middle and stuck the adhesive to itself to help prevent that. So there should be 2 layers of insulation between it. So there we go, we've got our shroud back on. Now, typically we need to double check this, especially when we're doing something so fundamentally wrong, but I'm forced to by the manufacturers because some genius in the company said, hey, let's do something wrong and stupid because we don't know how to do things properly. I think I'll leave the rant at that because I might end up insulting somebody eventually, but I still maintain there are many fundamental and wrong reasons for this. Fundamentally wrong things. I'm getting confused. Aftermath of the drugs. So let's see, this should be negative 9 volts. Okay, that's good. Crazy audio engineers. Maybe it wasn't audio engineers. Maybe they had a high school student design these things. I don't know. Alright, let's peel this off. Let's go and put everything back together, and we'll skip through to the bit where I plug it in and do the smoke test. And you can all laugh at me when the magic smoke escapes because I don't have any magic smoke replacement kits for all them components. Now the other really important thing we need to do here, before I get too much further, some genius, probably myself in the future, will come along and commandeer this plug pack to be used for something else. So we're going to scribble out these 2 little markers here and go, that is center negative and that is outer positive. Just so that anybody looking at this goes, hey, something fishy's going on here. Maybe it's not what we thought it was. So that's about as best I can do there. So you make sure you make a documentation, because that's what causes a lot of people to come unstuck, is the lack of proper documentation. And I'm going to write this on the back of the unit when I reassemble it too. Alright, so the smoke test time is upon us. Let's reach over through all the junk here and turn it on. In case you're wondering what that is, that's a prototype Nerf gun chamber. We'll talk about that when I build it. Alright, there's a power switch along here. Let's hope I don't get electrified, but we have an RCD, so alright, we have a power light. Let's check. Each one of these is coming on. We have a delay as well, so hold delay. I'm just going to set all these to their mid positions, just because that's good practice. Right, not sure what we've got going on here. Octave up, overdrive, all sorts of fancy stuff happening. Let's just center all of these just for good practice. Make sure nothing crackles or pops. Being the cretin I am, I don't exactly have anything in regards to equipment I can test this with. Do we have a pitch bank in here? Do we have to go right and edit? I actually really haven't read a manual about this, so I'm not quite entirely sure what I'm doing here. However, by the fact that all the lights are on and the fact that I was getting that bank to function before, I think we're doing all right. I did double and triple check everything. All right, so I think I'm going to call this done. This pretty well works, and we can still use batteries in it without force charging them, which would have been the problem had I done the mod I'd planned to. So it looks like it was just a case of stripping out this horrible, horrible death trap of a power supply. It stripped the casing off and everything. And this here is a big low ESR capacitor, about a 300 volt job. There's enough bite in there to give you a fair whack. It's roughly equivalent to what's in a camera flash unit. So, and if you notice in this, I'm pretty sure there's an LM78 series regulator in here anyway. This is probably only about a 1 amp or a 1.5 amp power supply anyway. Very similar to what I've put on it. So at least this looks like it's going to work. And I think even the power switch works. The next step, I think, is just to scribble on the back here that its voltage and its rating, because the designers didn't even see fit to write that on the back of this unit. You're going to do something non-standard and you won't document it. Recipe for disaster. Anyway, this has been a successful one. I'm going to get this back to my mate. The hour is almost upon me. I've got about 30 minutes. So I'll talk to you later. Hope you enjoyed this, and really let me know in the comments if you think things should be done differently.